Oh, wait.
All right, everybody. We're continuing with 3-2. All right? We're dealing with families of grass.
Are we on the map?
Yes. Families of grass. Now, if you see f of x plus a, that's different than if you have f of x plus a in the parentheses. One of these is dealing with a vertical translation. One of them is dealing with a horizontal translation. Which one is this one specifically dealing with?
Transition.
It is a translation, which means it's going to translate up or down or left or right. But this one, what does that one deal with? Vertical. So I want you guys to understand. It's a vertical translation. This one's specifically dealing with a horizontal translation. We'll be doing examples together while we're working on your assignment. The next thing you have to understand is the difference between a negative f of x and f of negative x. These are not dealing with translations. These are dealing with reflections. When you have a negative f of x, what is that dealing with? What type of reflection? This is a reflection across the x-axis. Very good, right? Sweet. Which means that this one would be a
Y-axis.
there we go. Reflection across the y-axis. So in your journal, I know you guys have already taken these notes, but this will kind of make everything more succinct, kind of, so you can just have one page to look at while you're working on your assignment. Doesn't have a whole bunch of pictures to go with it. I'll move back down. There we go. I'll pause. All right, now the part that's the most confusing, okay, for students, is the difference between when you have a number being multiplied to the function, or you have a function and you have the this particular a value being multiplied to the x's. All right. If the number's on the outside, it's going to be a vertical stretch, or it might be a vertical compression by a factor of whatever the a value is. So when you have a number times f of x, that's either going to be a vertical stretch or a compression by that exact number. Now, if a is greater than 1, that's where it's going to be a stretch. But if a is less than 1 but greater than 0, then that's what's known as what's called a vertical compression. Okay? And it's a vertical stretch or compression based off whatever that factor, whatever that number is. All right. The next one we're going to be talking about is what if the a value is right here on the inside of the parentheses. Now we're not dealing with a vertical stretch or compression, we're dealing with a horizontal stretch, or it could be a compression.
I wish I could get them on paper like that.
I'm sorry. Just go down on the next line, right? All right? Now, this is where it's going to be a little bit trickier, because if it's a horizontal stretch or compression, it's going to be by a factor of 1 over whatever your a value is. So if it's a horizontal stretch or compression, it's going to be, in the calculator, you put 1 over whatever your a value is. Okay? So in this one, I'm going to give you an example, all right? If the original function was f of x equals x squared. Okay? And the new function was, let's see, here's put g of x. G of x equals, I'm going to put in parentheses, 2x squared. Okay? This right here would be now, we got to know what a does before we finish this. So what I want to do right here, I'm going to slide this over real quick. You guys see how we have a is greater than 1? Okay. Now, if a is greater than 1, in this particular case, this is what would be a horizontal compression. If a is less than 1 and greater than 0, this would be known as a horizontal stretch. So make sure you have that down. All right. Notice on our example. Here's an example. What's this value? That's our a value, correct?
Yes.
Now, our a value is a 2. So our a value is technically bigger than 1, so we would say this is horizontally compressed.
So, but if the a value is 0.5, it would be stretched?
Correct. If the a value is 0.5, it would be horizontally stretched.
Alright.
This is where students mess up, though. This one would be horizontally compressed by a factor of what?
2 over a.
No,
1 over 2.
1 over 2. 1 over 2, because it's 1 over a. It's always 1 over a, not for the vertical, but for the horizontal stretch or compression. Okay, that's going to be what it's going to be compressed or stretched by, is by 1 over a. All right, so this right here, we're going to describe what's happening in relationship. This is our original function. Okay? This is the original function. Y equals, or f of x equals the square root of x. And there's going to be two things happening in this graph. The first thing that's happening is this graph's being multiplied by a third. The second thing that's happening is we have something inside of the radical sign. It's x plus 2. So what I want us to do for the first one is we're going to describe what does this 1/3 do to the graph. So if we go back to our notes right here, which one do you think it is categorized? This one on the left or this one on the right? Where's the 1/3? Is it on the outside or is it on the inside? Let's go back. It's on the outside. If it's on the outside, that lets us know that this is going to be a vertical stretch or a compression. What is our a value equal to? 1/3. Our a value is 1/3. Now, if a is less than 1 but greater than 0, that lets us know we have it's vertically stretched or compressed. You're right. Vertically compressed.
Is that it?
By a factor, no, it's not it, of. Now, if it's on the outside, let's go back to the notes real quick. If it's on the outside, it's going to be a vertical stretch. Now, we said it's going to be vertically compressed by a factor of whatever a is. Well, what is a? 1/3. So we would say this is vertically compressed by a factor of 1/3. That's one of the things that happens. Okay? It's vertically compressed. Now, what does vertically compressed mean? It means it's moving away from which axis? The y-axis. So it doesn't get closer to the y-axis. It actually moves further away from it. Well, let's just check. Get your graphing calculators. Let's see if we actually did that correctly. So turn your graphing calculator on. Hit the y equals button. I'm going to clear out these two. So I want you, in your graphing calculator, clear out y1, hit second x squared, and just type in an x and graph it. Just take a look at it. The square root of x. So right here is what it should look like, the square root of x. Now how do you get there? You hit second x squared, and that'll give you your radical sign. Now what I want you to do is type in 1 divided by 3. Now if you don't like 1 divided by 3 like that, you can also hit alpha y equals enter. Put the 1 there, and the 3 there, and then I want you to hit second x squared and type in an x. Right arrow. All right, and hit graph. Oh, here you go, Elise, right there. Okay. Does everybody see how this right here, this graph moved further away from the y? That got vertically compressed. It got further away from the y-axis. Okay? So that's why we call this a vertical compression. That's why it's called a vertical compression. Now, the next thing we have to worry about is this x plus 2 inside of the radical. So number 2, we're looking at this x plus 2 inside the radical. So if we go back right here, let's see here. Oh, which one do you think it's dealing with? The one here on the left, where the a is on the outside of that, or it's on the inside? It's on the inside. So we're dealing with a what? Horizontal translation. So right here, we're going to say this is horizontally translated two units. And now we have to decide whether it's 2 units to the left or 2 units to the right.
To the right.
2 units to the left. You're like, wait a second, how is it 2 units to the left? It says plus 2. But what number would get you back to that? Negative 2 gets you back to 0. Alright, so that's why it's 2 units to the left. Well, let's see if that's correct. If it actually does 2 units to the left. So go to your graphing calculator. Hit the y equals button. Go down to your second graph and go inside the radical. So go right here inside the radical and type in, right here, type in a plus 2. And now let's see if it moves 2 units to the left. It does. So you see right here, this is where it was. Now where is it? It's actually starting over 2 units to the left. So it went 2 units left. That's what we're going to be doing on all these. You have to look at what's happening. How many things happened in this graph? 2 things. One, it was vertically what? Vertically compressed. The other, it was translated 2 units to the left.